All right, welcome to lesson 9.1. This is on adding and subtracting polynomials. In this section, you're going to learn exactly what a polynomial is and then how to add and subtract them. So first, we have some different vocabulary words that we're going to need for this section. So if you look, these are our key vocab words. We've got monomial, degree, polynomial, leading coefficient, binomial, and trinomial. All right, so let's go over what these are. All right, so first it says a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. For example, this could be like 10x squared or, 15b, okay? Something like that. The second part is the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables in a monomial. For example, you could say the degree of, well, I'll just show you. For example, a monomial could be 10. The degree is 0 because there is no exponent. For this one, 3x, you could say because x is the variable, that it has a degree of 1, okay? 1/2 AB squared. A has a degree of 1, B has a degree of 2, so 1 plus 2 equals 3. So that's how we get the degrees, okay? It is only based on the variables, so the letters, okay? Some examples of not a monomial would be 5 plus x. When you have a sum, it's not a monomial. 2 over n, you can't have a denominator with a variable in it. 4 to the a power, I know it's kind of hard to see, but 4 to the a power is not 1. And that's because we cannot have a variable in the exponent. And then anytime you have a negative exponent, so for example, x to the negative 1, we can't have that, okay? All right, so that's monomial and the degree of a monomial. All right, now a polynomial is a little bit different. A polynomial is a monomial or a sum of monomials, okay? Each called a term of the polynomial. So for example, this could be like 4x plus 10. That's considered a polynomial because there are two parts to it. We're adding it, we're finding the sum, and then the 4x would be a term and the 10 would be a term, okay? And then the degree of the polynomial is the greatest degree of its terms. So for example, in this particular example, 4x plus 10, the greatest degree I have is 1 because this x has a 1. So the greatest degree would be 1, okay? If I had, let's say, 3x to the third plus 2x squared plus 5. The greatest first of all, each term would be 3x cubed, 2x squared, and 5. My degree would be 3. The reason my degree would be 3 is that this is the highest degree of all of them, okay? All right. The next information or vocab word that we need is the leading coefficient. When a polynomial is written so that the exponents of a variable decrease from left to right, the coefficient in the first term is called a leading coefficient. So again, let's take this 3x cubed plus 2x squared plus 5. If I look at this example, my leading coefficient is going to be 3. That's out front. All right, so just like here, we've got 2x cubed plus 2x minus 5x plus 12. Okay, we've got a leading coefficient was our 2. Our biggest degree of the polynomial is 3 because that's our largest one. And then we have the constant term, which is just our number by itself. So in this case, it would be 10. In this case, it would be 5. In this case, it's 12. Okay. Couple vocab words that I don't have on here are binomial and trinomial. A binomial is basically like this. where it has two terms. A trinomial is just like it sounds, tri, so it would have three terms. Okay. Anything beyond a binomial or a trinomial, having two or three parts, is just considered a polynomial. So for example, this guy down here, it's got four terms, so it's just considered a polynomial. All right. Now, one thing I want you to notice, I'm going to show you this in the next example, is how this is written. If you look, we always want to write our polynomials with our degrees, our exponents, in decreasing form, ending with our constant term. So if you notice, this one has x cubed, then x squared, then 5x, and 12. Okay, I'm going to show you an example of that now. So we've got, it says write 15x minus x cubed plus 3. So the exponents decrease from left to right. So if you look at our solution, we immediately have 15x out front, which is only a degree of 1. We've got negative x cubed, which has a degree of 3, and then we've got positive 3, which just has a degree of 0. We want to reorder these so that they go in from greatest to least degree. So if you look right here, they have done that for you. Okay? Always remember to take the sign that is in front of the term. So for example, negative x cubed is going to be our first term. Positive 15x is our second, and then 3 being our constant term is going to be at the end. Our greatest degree is 3, and because we have this negative sign in front of x cubed, my leading coefficient is negative 1. All right, so that's how you would rewrite a polynomial in the correct form, with it being the exponents decreasing from left to right. All right, so let's go into the main part of, or one of the main parts of our thing. We want to be able to identify and classify the polynomials, whether or not a polynomial is in fact a polynomial. So it says tell whether it is a polynomial. If it is a polynomial, find its degree and classify it by the number of its terms. Okay. So our first expression is 9. Is this a polynomial? It actually is a polynomial. Okay. Because it has 0 degree and it's a monomial. Okay. It's still considered a monomial. 2x squared plus x minus 5 is also considered a polynomial. Okay. It has a degree of 2. Okay. And it has 1, 2, 3 terms, so that's why we would call it a trinomial. All right. This next one, we've got 6n to the 4th minus 8n. This is not considered a polynomial. Reason being, I've got this variable as an exponent. Anytime I have a variable, like I said at the very beginning, as an exponent, it doesn't consider it a polynomial. All right, then we've got n to the negative 2 power minus 3. Again, this is also not considered a polynomial because I've got this negative 2, okay, up here, and this should say negative exponent, not variable exponent. Because I've got this negative 2 in here. All right, this last one, we've got 7bc cubed plus 4b to the 4th c. This is considered a polynomial, and my biggest degree is going to be 5. The reason it's going to be 5 is if I look here in this first term, 7bc cubed, b has a degree of 1, so 1 plus 3 is 4, so this term has a degree of 4. And here we've got b to the 4th and then c to the 1, so 4 plus 1, so this guy has got a degree of 5. So this guy is considered my degree since it's the largest one, so 5. There are 2 terms, making it a binomial. All right, to just know how to classify whether or not it's a polynomial or not. Okay. All right, now the main part of our lesson today is going to be knowing how to add and subtract these lovely things. So we are going to, I'm going to start with this example right here. We've got 2x cubed minus 5x squared plus x plus, in parentheses, 2x squared plus x cubed minus 1. Okay? Immediately you should notice something. This guy is not written in correct form because x cubed should probably be out front. But we are going to start combining our like terms. That is the main thing when you are adding. That's the great thing about adding. You're just combining your like terms. So I'm going to use different colors, and I am going to underline my like terms with different colors. So I've got 2x to the cube power. So that's one term. And since it's x to the cube power, I can only combine it with another term that has x to the cube power. So I'm going to go over here. Well, positive x cubed is going to be my first common pair. Okay. My second term is negative 5x squared. I am going to combine it with another guy that has x squared in it. So 2x squared is considered my common term here. Okay. Then I've got x, and he can't combine with anything, so he's going to be out here on his own. And then I've got negative 1, and negative 1, again, cannot be combined. Okay? All right, so now I'm just going to start combining my terms. So right away I'm going to take 2x cubed plus positive x cubed. So 2x cubed plus x cubed is going to be 3x cubed. Okay. Then I'm going to take my second one. I've got negative 5x squared plus 2x squared. Negative 5 plus 2 is negative 3, so I'm going to have negative 3x squared. My x does not combine with anything, so I'm just going to move him down, plus x. My negative 1 doesn't do anything, so it's just going to be minus 1. And this, folks, is my answer. 3x cubed minus 3x squared plus x minus 1. Simple as that. All right, let's look at another example. If you want to pause right now and try it on your own, I would do that just so you can get some practice. Otherwise, I'm going to go through the solution right now. Okay, so I'm going to go through and I'm going to point out my common denominators, my common terms again. Okay, I've got 3x squared and x squared. I've got x and positive 4x. And then I've got negative 6 and 10. All right, so I'm going to go through and start adding. 3x squared plus x squared is 4x squared. Positive x plus 4x is going to be 5x. All right, and then negative 6 plus 10 is going to be positive 4. Easy enough. All right, adding polynomials, not too difficult. All right, subtracting polynomials is a little bit more complicated. All right, the reason subtracting polynomials is a little bit more complicated is that because we are dealing with a parentheses right here. So because we have these parentheses right here, it makes it a little bit more complicated. Meaning I need to, and this is going to sound funny, distribute the negative sign to everything on here. Okay, if you remember, we did do this with the distributive property. We talked about distributing this negative sign to each term on the inside. So I'm going to do that right now. And I'm just going to rewrite my problem. Okay, so I am going to look at it this way. I'm going to just still write out my 4n squared plus 5 because this guy out front doesn't get affected by anything. He's just hanging out, okay? Now I'm going to distribute my negative sign. So negative times negative 2n squared is going to become positive 2n squared. Negative times positive 2n is going to become negative 2n. And then negative times negative 4 is going to become positive 4. Okay, now all I need to do within this is start combining my like terms. So I've got a 4n squared and a positive 2n squared. I've got a 5 and a positive 4. And all alone I've got this negative 2n. Okay, so I'm going to rewrite this. So 4n squared plus 2n squared is 6n squared. I'm going to make sure that my degrees are in the correct order, so I'm going to hop over here and I'm going to go negative 2n. He doesn't have anything to combine with, so he's just going to hang out over here by himself. And then plus 5 plus 4 is 9, so plus 9. So my answer is going to be 6n squared minus 2n plus 9. All right, so when you're finding the difference, it's just one extra step from finding the sum. You're just going to distribute this negative sign to every term within the parentheses afterwards. So last example of this video, just if you want to try it on your own real quick, I would do that. Otherwise, I am going to rewrite my question right now. Okay. So again, all this stuff in the first parentheses is going to stay the same, so I'm just going to rewrite it. So 4x squared minus 3x plus 5. And then I'm going to start distributing my negative sign. So negative times 3x squared is negative 3x squared. Negative times negative x is going to become positive x. And negative times negative 8 is going to become positive 8. And I'm just going to combine my like terms. So my like terms, 4x squared and negative 3x squared. Negative 3x and positive x. And positive 5 and positive 8. So I'm just going to rewrite it. Positive 4x squared minus 3x squared is going to become 1x squared. Negative 3x plus x is going to become negative 2x. And positive 5 plus 8 is going to be 13. And there's your answer. One thing to point out, you do not need to include this number 1 here because it's implied. So if you wanted to rewrite this as just x squared, that would be the more correct way to write it. However, if you do write the 1 in front of it, it doesn't make it wrong. Okay? All right, that's all I have for you guys. Let me know if you have any questions. Thanks.